The third polynomial theorem is going to be the fundamental theorem of algebra. Honestly, I think this is probably the easiest one because it tells us the degree of solutions or zeros a function has, both real and imaginary. The reason I like this one the most is because it's simple. It is equal to the degree of the polynomial your real roots cross, touch, intersect, meet. Your imaginary or irrational come in pairs. Note here that only imaginary does not cross x-axis. So irrational can, but imaginary does not. Okay. I will graph to first identify my real, then subtract that amount from the degree to get the number of imaginary roots. So what this means is I come in here and I find the degree. So 5, 3, 2, 1, constant. So 5 is bigger than 3. 5 is bigger than 2. 5 is bigger than 1. 5 is bigger than 0. So my degree is 5. So I know there are blank real, blank imaginary. All right. So to figure this out, just pull up Desmos. I can go y equals, or f of x equals x to the 5th minus 5x cubed plus 6x squared minus 14x plus 12. And if I look, it touches it at 1, 2, 3. So there's 3 real. So 5 minus the number of real tells me my imaginary. So degree minus real equals imaginary. So there are 2 imaginaries. So that's all we're going to do here. Okay, now you may need to zoom out a little bit to find zeros that aren't in or aren't possibilities. But what I was saying earlier about how these come in zero or how these come in pairs, so the options would have been, for this one, it would have been 0, 2, or 4. It couldn't have been 6 because that would have been too big. If there were 0 imaginary, there would have had to have been 5 real. If there were 2 imaginary, there would have had to have been 3 reals. And if there was 4 imaginaries, there would have been only 1 real. Okay? So just make sure the number of reals adds up, or the number of real and the number of imaginary add up to get you your degree.